Learners really excited to have the CEO of OpenCV with us, Satya Mallick, to share his insights in this expert session. Uh, Thank you, Satya. Thank you for taking out time for this discussion. Really appreciate.
Thank you so much for inviting me.
So, you have an extensive experience in the field of computer vision and machine learning in general. Can you walk us through your journey and also maybe talk about some challenges, some milestones uh, that you faced throughout this journey?
Right. So I started my journey back in, when I did my undergrad from IIT Kharagpur, and I graduated in 2001. My final year project I decided to do in computer vision just by accident. I was in during summer. I stayed back, and one of my seniors, he was doing something with a robot, and I just writing some image processing kind of code. So I went to him and I asked him, what are you working on, and is it some image processing project? And he got offended, right? He said, oh no, this is a computer vision project. And I said, what is computer vision? He said that, image processing is image in and image out, and you're basically modifying the image. But in computer vision, there is image in and information out. I said, wow, that's really good. So then I got motivated. I got this new idea. So I took my final year. My final year project was in computer vision, and then I applied to universities in US for for my PhD, and that was in computer vision and AI. And that in that time, it was all traditional computer vision techniques. Deep learning was not even in the techniques were known, but nobody actually used them, right? And then in 2006, I started a company with my PhD advisor. It was called TAS, and it created a virtual makeover solution for women. Women could upload their own picture and apply makeup virtually, right?
Oh, interesting.
Yeah, it was back then, and we had a very good run. We were on Oprah magazine. Our clients included Bloomingdale's, InStyle magazine, People magazine, all these big clients. But ultimately, because of some business reasons, we failed, and I made $0 million from that. After that, I decided I'll do consulting in computer vision and AI, and I started growing a consulting company, which is Big Vision. And I was also simultaneously writing learnopencv.com. This is a blog I have about computer vision and machine learning. And people started saying that, oh, why don't you create a course and we'll buy it? And I said, why don't you buy the course first and then I'll create it? So we did a pre-sale for a course, and a lot of people bought it. We delivered the course. And then I got in touch with the founder of OpenCV, and for creating courses for OpenCV. And so the founders, we worked together, and he said that, oh, why don't you be the CEO? I like you, and things like that. And so things worked out. So we have courses on OpenCV, and I became the CEO of OpenCV. We drove many initiatives. So my main goal was that OpenCV should become the place where conversations about computer vision happen, not just the OpenCV library, which is great. I mean, I used OpenCV library since I was a grad student, right? So it was an honor. But at the same time, I realized that computer vision is growing beyond traditional computer vision techniques, right? So we decided to do courses. We also worked with a company called Luxanis to create OpenCV AI Kit. We actually did a Kickstarter campaign for that, which was $1.35 million. And another Kickstarter campaign the following year, which was $1 million. So we were suddenly working with hardware as well as software, and of course, training material. So that's briefly, where my career, various aspects of my career came together.
Very interesting. And you mentioned about the OpenCV library, right?
Yes.
So anyone who has worked in the field of computer vision, I don't think there's anyone who would not know about OpenCV's
Right.
library. Right? It's been a very instrumental and very inherent part of computer vision. Can you share some, let's say, new developments which are going to happen in the library?
Yeah, just to set up the thing, people, even though people have used OpenCV for a very long time, many people don't know some of its history. And one of the most spectacular part of the history is that there's this competition that DARPA had organized, and in 2004, I think, and 2005 also, for autonomous vehicle. So they had a stretch of 132 miles in the Mojave Desert. And there were several teams that competed in that competition. It was a $2 million prize, whoever completes that track. And in 2004, none of the teams competed. In 2005, the team that completed was a team from Stanford, and the name of the car was Stanley. The name of the computer vision library they used was OpenCV, right? And the founder of OpenCV, Gary Bradsky, was also part of that team, right? So that it's so the OpenCV has evolved from there, and we have now, after some time we had the C++ API. Initially it was a pure C API, C++ API, and then somebody from the community, they created a Python package for it. We had Python bindings, but they created the Python package for it. And so the library has grown substantially. Now it's downloaded about 2 million times a week, right? So now moving forward, first of all, we are looking at OpenCV 5. And for OpenCV 5, we are actually going to reach out to the community and again do a Kickstarter campaign to raise funds for and also know what are the features we are interested in, right? So that will expand the library. Some of the things that we are already thinking about is adding new kinds of calibration techniques. We are also going to add support for not just, right now it's a CPU library with GPU support, but we want to expand it to new kinds of edge devices which use NPUs. And so the thing would be optimized for phone and NPUs, etc. So that's in the horizon. There is another thing that is brewing right now. It is not 100% concrete, but Gary Bradsky, who is the founder of OpenCV, he's taking a lead on it, that OpenCV would like to become the place where all the models for 3D information is stored, right? So there is a new kind of structure called NERF. Basically, it's a compact way of saving 3D information about a scene in a neural network. So it's a compact way of storing that. And we want to become the repository where people upload all 3D NERFs, and then we will have a data set. So one of the problems with all the generative AI stuff is that nobody knows the origin of the photos that have gone into it, right? So if you want to take that concept to videos, right, and 3D, then we have to be very certain that we pick the right data set. And if we create this NERF data set where community, there is a lot of community engagement, and they also submit data sets, in that case, we can create a very large data set that the community has certified that they have actually taken this picture and they have not just copied it from somewhere, right? Yeah. So once you get that certification, you get a very clean data set, and based on that data set, people can create 3D models as well as video generative videos using that.
This application is very fascinating and interesting, right? Because this is one of the major concerns while training not just generative AI models, but any kind of models, that you have to use images which have a proper attribution, which have proper copyright concerns, and so that's very interesting use case.
Yeah, and whenever we have reached out to our community, they have responded very positively, and that's why we want to make sure that because OpenCV has this trust, the community members would join in and bring their data, which, it's not very difficult to capture this data. If the interface is right, then people will contribute. Right. And once you contribute, you also get back from the community, right? Because once you become a member and contribute to the code, you also get 10 other models that you can use, right? We will come up with, the details are not being decided yet, but the idea would be that you participate, and in return, you get 10x of what you have contributed.
Oh, that's very interesting. Yeah. Nice. Right, so you have worked on various computer vision projects yourself as well, right? Can you name a few which were your favorite or which created the most amount of impact?
Impact-wise, I cannot name the company, but we do consulting services through a company called Big Vision LLC, and we work with as startups as well as large companies. One of the companies that we worked with actually does identity fraud detection. So various kinds of ID cards like passports and driver's license, etc. You take those ID cards, and sometimes they are fake, right? The photo may be fake in that the information on the uh, on the card may not match the magnetic strip, and so on and so forth. So we work with a company that detects ID fraud, and the impact on it is huge. There are companies that have saved millions of dollars on it. It is also used very widely in the world. I cannot name, but you can imagine, about 300, 400 million people use that system, but nobody knows that we built it because those are restrictions.
A very interesting project.
Yeah.
The field of computer vision has seen a lot of developments, right? So, and in the overall timelines, uh, not very, let's say, long timelines as well, right? So, let's say image classification became a mainstream application maybe in 2013, right? So, uh, and then we had more advanced applications like object detection,
Yeah.
segmentation. What is next for the field of computer vision now?
Yeah. So image classification, object detection, segmentation, these are very classical problems, have been around for a long time. The solutions, on the other hand, they were not good until 2012, when the first, deep learning based model changed everything. Now, there was this competition called large scale image recognition challenge, ImageNet challenge. Um, and that was started in 2010, and only the top 5 accuracy, I cannot remember off the top of my head, but it was about 73% or something like that. And the next year, 2011, it was 75% or so. So we were making small incremental progress, and in 2012, Jeffrey Hinton's paper came out, and that beat everybody by more than 10%, right? And we got 85% accuracy on image classification. And once that has been established, right, that, oh, this technique actually works, deep learning actually works, uh, there was nothing stopping it, right? And that's why the same technique was applied for object detection, for image segmentation, because they are all related. Once you understand, what features are useful for doing image tasks, then the same features are used for different tasks, right? Improve different tasks. So the next phase is exactly generative AI kind of approach. Now you may think that what has changed, right? Now initially, let's say you want to solve an object detection problem, right? You want to solve a pedestrian detection problem. In that case, you get a lot of images of pedestrians. You don't have a concept of pedestrian. You get a lot of images of pedestrians. You train the model, and it gives you a pedestrian detector, right? But what it did not take into account was the fact that there are millions of images of pedestrians on the internet. Those images also have a caption attached to them, right? And that caption may say the word pedestrian or a person or something. So you could technically get all the information for free, right? Because there is this combination of text as well as images. And that is exactly what happened with Stable Diffusion, right? We were informed by these large language models to solve a vision problem, right? So now you can tell Stable Diffusion to create a picture of a cat, even though it was never trained specifically for cat, right? It was text on image and text pairs, and they created that's how it was trained. So now vision has an understanding of the world through these language models, right? So there is a convergence of all these techniques. Large language models are converging with vision models, and so we are getting these very sophisticated solutions where you don't separate out parts of AI anymore. They are all converging together, right? So that's how it's progressing. That's the next frontier.
Makes sense. And it's already happening, right? So we already have so many tools
Yeah.
which have started creating images for us
Yeah.
using generative AI tool. But as you mentioned that there's going to be more research happening in this field, and
Yeah.
we'll get even better results.
Yeah, and not just like research in universities. You should, I mean, you probably have seen this memo by a Google engineer, which was leaked, and he was saying how open source is the advantage all these models have, right? And he specifically picked the example of stable diffusion. It was released at a certain date, and within weeks, somebody is doing adding new features, somebody is doing retraining it, somebody's the model which used to be much bigger is now much smaller. All these things happen because it's all open source. Sometimes they are also like hacks, right? And there's this beautiful book called, I think, the Bazaar and the Cathedral, or the Cathedral and the Bazaar, where cathedral is the university setting where everything is pristine and you have to work with it, and the bazaar is, it's all messy, but innovation is happening there, right? And the same thing is happening with open source. It's a very messy environment. It's not like some of the techniques that are suggested. They look, from a theory point of view, they look, how can you use this? But they work, right? So we have to accept, and we will refine the theory around it, right? But the open source community is just running with this, and that is leading to very fast innovation, and will understand how things work. But the beauty is that we are now seeing things are working, and the understanding can come later. In fact, uh, the if you look at the history of air flight, people still don't understand 100% how planes work. Absolutely. Right? It is, but simulations, when they do simulations, when they do testing, etc., they know that, okay, this flight it is going to stay in the air, right? But there are these nagging questions people still have about how exactly it works. But that doesn't prevent people from using it, and that makes life easier for them.
And earlier we were talking about object detection,
Yeah.
right? So there are some very common use cases of object detection which all learners try out as projects, right?
Yeah.
So identifying pedestrians, identifying traffic lights,
Yeah.
identifying wildlife animals.
Yeah.
Can you tell us some more interesting ideas for object detection so that our learners can probably do more innovative projects?
Right. So, I mean, in the industry, if you have a standard problem like that, people will easily solve it, right? But when people come to us for solving these kinds of problems, there is some amount of difficulty in it, right? One could be that two classes are very close to each other, right? They look very similar to each other. How do you now? Then you need specialized knowledge to make sure that you are able to disambiguate between the two classes. The other could be that the shape is very odd, like it could be a very long shape, it could be very small objects. So those kinds of techniques, right? Then you need slightly different techniques, slightly different architecture. Sometimes you use different heuristics on top of the results you get. So um, there are standard problems that you need to solve, but most of the time you will get specialized hardware. But it also goes in the other way. Sometimes we are able to, like, there was an industrial problem where they wanted to detect a particular object, and they had very few example videos for us, right? But we noticed that this is an industrial part. We went and searched for the part, and we found the 3D shape of the part. We used a 3D rendering engine to model and render that kind of part, and we just created synthetic data, right? So now it became, using synthetic data, we were able to solve the problem. So it was not a difficult object detection problem, but the data was not there, right? Similarly, for this ID card company, because they could not give us data for ID cards, that would be, there was a small sample where they had permission, but that was not enough to train, let's say, a text detection model. So we downloaded all the images, all the addresses of people in the United States. That's public information. All the street addresses. We downloaded all the common names, right, on common last names, and we simulated what an ID card would look like, right? And now you could create a 10 million image data set, and you basically have all these combinations, and we were able to train an text detector using that. So sometimes, the problem is not how hard the problem is, but it is that you don't have the data, right? Or sometimes it is actually hard, right? You're unable to disambiguate between two classes, things like that. Yeah.
So I'm guessing the message for the learners then is that after they go through the simple problems,
Yeah.
as you mentioned, right? So then they should look at more industry relevant, more complex problems,
Yeah.
where let's say the objects are close to each other or the objects are very, very small,
Yeah.
so that they can get that better learning experience.
Yeah. So, and they should read about various things that are going on in the industry, right? Because once you, let's say, you want to go get a job in the field after you've taken a course, they will try to poke, right? It's a different, they will try to understand how you go about solving a problem, right? So they'll give you these examples of problems that if you are suddenly surprised, they will know that, okay, this person has only solved toy problems, right? The other thing is that for people who have um, gone through some of these courses, can you create recipes for yourself, right? That if you get this problem, this is how you solve the problem. Because again, in a job interview, when they ask you a question, a simple question like, oh, my model is not giving me high accuracy, what should I do, right? And the naive way to think about it is that people immediately start giving an answer, right? They say, oh, you should collect more data, or you should do, you should try a different model architecture, etc. But that's not how it should be done, right? The way to go about it is that you obviously look at your training error. If the training error is not low, right, then you have to gather more data, right, and things like that. So basically, if you also have to train longer, etc. But most of the time, right, you don't need a new model architecture, right? Most of the time, a standard architecture, it has worked on so many problems, it is going to work for your problem, right? It is never a model architecture. Usually you can get 1% improvement by changing the model architecture, right? But if you're at 70% accuracy for a simple image classification problem, that's not really your problem, right? So you should have recipes for yourself to know that, okay, if this is the case, this is what needs to be done, right? And in certain cases, you may need additional data. If nothing works, maybe you need to change the model architecture, but most of the time, you don't need to do any of those things, right? And that is the kind of answer people expect in a job interview, right? That you have recipes for solving the problem.
And very interesting that you mentioned that learners should have a reference guide on what to do when a particular scenario
Right.
is there, so that it's like a ready reckoner for when they face complex
In
problems.
fact, I was working with a client, and there were some engineers on their team as well, and we were getting this I don't know, very low accuracy, 70% accuracy on an image classification problem. It was a 10 class classification problem for medical data, and the results were just, I could not believe it was so bad, right? When we first trained the model. So the person on their side, the engineer on their side, he was saying, "Oh, why are you using a backbone which is like 2 years old? Why don't you use this new one that has come out?" I said, "No, that's not a problem, right? With a new backbone, maybe you'll get 1% if lucky, right? That's not a problem. If you're getting 70% accuracy, there is something fundamentally wrong with the data." So we went and talked to the doctors because we could not interpret this data. We talked to the doctors, and turned out that some of the doctors had labeled something as left based on whether it was the left hand side, and some of the doctors had said it left based on whether it was the actual left, right? So the left and right concepts were switched. So the data was garbage, right? So we worked with the doctors again, and they labeled it consistently. Then it shot up to 92, 93%. Now you can improve the results, right? You can change the model. I mean, you can do a lot of things, but seeing something which is at 70%, that should immediately give you this idea that no, either you've messed up the training in some way, but most likely it is the data, right? A lot of people don't understand that changing the model architecture, even tuning the parameters, etc., that all those things give very small accuracy. Go look at the data, spend the time with your data, and that is not taught in in universities, right? A lot of people don't have never even sampled ImageNet, right? If you go and look at ImageNet, you'll see how biased it is. Like a large percentage of images, I don't know exactly how much percent, but more than, let's say, 30% of the images are that of dogs.
Okay. 30%.
Yeah, a huge number, right? I cannot.
Large portion.
A large portion is dogs, and the reason is that they wanted to use ImageNet um, for this standard image classification, but they also wanted to collect data for fine-grained image classification. So that you can tell different breeds of dogs apart, right? But if you search only the dog class, all of them are included, right? So there is a very big mismatch, right? So you need to know, you have to spend time with your data, which a lot of people don't do, unfortunately. And that's where all the big gains are.
So, quite interesting that once you get some results, and that 70% benchmark is also quite helpful, right, for learners, that if they get performance lower than that, then it's probably not the model. It's the problem is elsewhere.
Yeah, it depends on the problem, but you can look at a problem, right? And if as a human you are able to tell things apart, right, then a machine should be able to tell things apart as well. So you and by working on in the field for a long time, you will know, you'll get a sense of, okay, for this kind of data, 70%, no, it should be, we should start at 90%, and then we have to improve the results. But 70% something is terribly wrong, right? So you have to get that intuition for by just working on it. There's no other way to get it. Yeah.
Makes sense. So this field is constantly evolving, right? How do you keep track of all the developments which are happening, particularly in computer vision?
You can't. Things are moving so fast that it is impossible for you to keep track of everything. But our strategy is to slow down a little bit, right? Build deep expertise in things that we know, but also not always chase the shiny new object. And I'll give you an example of from a few years back. There was this idea called capsule nets, and it was by Jeffrey Hinton, which is one of the, he's one of the godfathers of the field. So everybody jumped into capsule networks. They started doing this work, and our strategy was that, okay, we'll wait for a few months. If it actually is useful, and they were saying that it's going to, all the standard architectures will change, but nothing like that happened, right? So we just waited it out, and that's a perfectly fine strategy, right? You don't have to be the first to know everything. Good ideas will be adopted by the community, right? Some people will be very passionate about it, and they will create something. They will provide you evidence of what is going on, right? So being a little behind is perfectly fine. Otherwise, you'll just go crazy chasing chasing these new developments.
Right, definitely true. Um, so, lastly, any message that you would like to share with our learners who are starting their journey in the field of computer vision?
Yeah. So the message is very simple, right? This field is in its infancy, right? AI is a rocket ship that is taking off, and we are very lucky. If you are starting out in this field, you're very lucky to be in the right place at the right time, right? So there are very lucrative jobs available in the field. For example, in US, I did a Google search, and I found out that an entry-level AI position in the US, the average income is $126,000. Right? Incredible. You cannot believe people are offering that kind of salary, because there is a very big mismatch in the demand and supply, right, of good people, right? You can find people who are just superficial, right? There are a lot of people like that, but there's a mismatch in demand. So first of all, be thankful that you are in this field, and it's a very good field. The other thing is that you have to realize that it's in its infancy, so nobody has years of experience, right? And even though you may have years of experience, a lot of that experience is irrelevant. All the things I did during my PhD, it's irrelevant knowledge, most of it, right? Because they have been replaced by new stuff that has come out recently. So that's an opportunity for you. For example, take this example. Elon Musk hired Andre Karpathy as the head of Tesla AI for the autonomous driving unit 1 year after he graduated from Stanford, right? Because it's not like he has years of experience. He has exceptional skills, right? And that's what you need in computer vision and AI these days, If you have the right skills, you don't need years of experience. In fact, nobody has years of experience, so you should capitalize on this wave. Dig deep and build a very solid foundation for yourself, and then your career, you'll be pleasantly surprised how spectacular it can be.
So it was a wonderful session, Dr. Satya, and really pleased to have you over here and talk to our learners. Thank you again for taking out time for this session.
Thank you so much.